Hi everyone, here is part 2 of our probability theory lecture. So by now you should have already done the probability exercise and have gotten familiar with the steps to understanding probability of events occurring. Here in this lecture, I'm going to cover 3 general rules and properties that we will see in probabilities. The first is that the probability that any event occurring, so the probability of any event A or PR of A, is a number between 0 and 1. So this means that all events have some probability of occurring. That probability may be small or it may be large. However, the probability of an event occurring will never be negative, and it will also never be more than 100%. So thinking of this in some more mathematical notation, the probability of any event or event A occurring will always be between 0 and 1. Or in plain English, a single probability can only range from 0% to 100%. There is no such thing as a negative probability, and there is no such thing as more than 100%. So everyone who tells you give 110% or give more than 100%, that's simply nonsensical. You can only have a probability up to 100%. So that's rule 1. Rule 2. The occurrence of all possible outcomes of an event have a probability of 1. So this can be notated as a sample space S. And within a sample space S, the probability of all possible outcomes occurring is 1. Or another way of saying this is the probability P or PR of all possible outcomes will sum up to 1 or 100%. So if we go back to the flipping coin example I talked about earlier, we have 2 outcomes of this event, either landing on heads or landing on tails. That's our sample space, heads or tails. Those are our 2 outcomes of the event of flipping a coin. The probability of landing on heads is 1/2 or 0.5. The probability of landing on tails is 1/2 or 0.5. And therefore, the probability of either outcome occurring or the full sample set or sample space is equal to 1. So that's the notation. And in plain English, when you add up the probability of every single possible outcome occurring in a given event, it will all add up to 100%. So when you have a coin toss and your possible outcomes are heads or tails, the probability that you're going to get one of those 2 outcomes, that's going to be 100%. The probability of every single possible outcome occurring added up will get you to 100%. Rule 3 is the simple additive rule for mutually exclusive events. So this rule is premised on you already having a grasp of knowledge of the term mutually exclusive. And I talked about this before in the example of rolling 2 dice. So imagine I roll 2 dice. If I get some outcomes, can I roll both a snake eyes and a 4? Well, snake eyes is 1 and 1, that's a 2. If I rolled snake eyes, can that also be a 4? Absolutely not, because this is a mutually exclusive event. When I roll my set of 2 dice, only one outcome can occur. I'm either going to see, maybe if I get a 1 and 3, I can't also get a 2 and 2. So in this mutually exclusive event, the probability of observing different outcomes is additive. I'm adding up the different probabilities. So in the example before, if I'm looking at the probability of rolling a 4 across 2 die, this can occur with 3 different outcomes. So outcome A is rolling a 1 and a 3. Outcome B is rolling a 2 and a 2. and outcome C is rolling a 3 and a 1. So here if we say, well, what's the probability of A or B or C? It's a simple additive rule. It's the probability of A plus the probability of B plus the probability of C. So here for rolling a 4, the probability of getting that outcome is equal to the probability of getting a 1 and 3, or getting a 2 and 2, or getting a 3 and 1. And I'd add those three up. I'd add up the probability of getting a 1 and 3, the probability of getting a 2 and 2, and the probability of getting a 3 and 1. In plain English, if only one outcome of an event can occur, in the case of rolling 2 dice, only one outcome is going to occur. I can't get both a snake eyes and a 4. So if only one outcome can occur, the probability that any one of multiple outcomes occurring is the sum of the probabilities of each individual outcome. Or in the case of these 3 die rolls, it would be the probability of rolling a 4 is adding up the probability of getting the 1 and 3 plus the probability of getting a 2 and 2 plus the probability of getting a 3 and 1. That 1 out of 36 plus 1 out of 36 plus 1 out of 36. And those are our 3 rules that are governing probability of events. Thank you very much.